Using recording ammeters to determine actual load is a valid method for existing buildings after occupancy. Load calculations are indeed useful for sizing services during design, but they may not accurately reflect the real-world usage patterns. Recording ammeters offer several advantages, including real-time monitoring by recording load data over a period, providing a continuous picture of actual consumption. Another advantage is load profiling by identifying patterns of usage, including peak loads, demand profiles, and imbalanced loads. A third advantage is data accuracy by providing measured values of current, which can be used to calculate power and energy consumption. When performing the procedure, firstly, install recording ammeters on each ungrounded conductor. Secondly, monitor for a sufficient period, for example, 1 week to several months, to capture typical usage patterns. Thirdly, analyze the recorded data to determine the maximum demand, average load, load factor, and unbalanced loads, if any. There are some limitations. Firstly, installation costs, since recording ammeters can be expensive to purchase and install. Secondly, data interpretation, since analyzing and interpreting the recorded data requires technical expertise. Thirdly, occupancy changes, because if the occupancy patterns change significantly during the monitoring period, the results may not be representative of typical usage. Recording ammeters are commonly used by electrical engineers and utilities to firstly, verify load calculations, secondly, troubleshoot imbalanced loads, thirdly, identify opportunities for energy efficiency measures, and fourthly, size electrical equipment based on actual usage data. While load calculations are essential for design purposes, recording ammeters provide a valuable tool for determining actual load in existing buildings. By monitoring load patterns over time, engineers can gain insights into occupant behavior, identify potential issues, and make informed decisions about electrical system maintenance and upgrades. When installing recording ammeters, it's crucial to consider several factors to ensure accurate and reliable data collection. Firstly, select the appropriate type of recording ammeter for the specific application. Different ammeters are designed for different voltage and current ranges, as well as different environmental conditions. Secondly, ensure that the ammeters are properly calibrated before installation. Calibration ensures that the ammeters are measuring current accurately. Thirdly, install the ammeters in a safe and accessible location. The ammeters should be protected from physical damage and environmental hazards. Fourthly, connect the ammeters to the appropriate conductors. Ensure that the ammeters are connected to the ungrounded conductors of the circuit being monitored. Fifthly, configure the ammeters to record data at the appropriate intervals. The recording interval should be short enough to capture the variations in load, but long enough to avoid generating excessive data. After the recording ammeters have been installed and configured, it's important to monitor the data regularly to ensure that the ammeters are functioning properly. Check the data for any anomalies, such as sudden changes in current or missing data points. If any anomalies are detected, investigate the cause and take corrective action. When analyzing the recorded data, it's important to consider the following factors. Firstly, the time of day. Electrical loads typically vary throughout the day, with peak loads occurring during periods of high demand. Secondly, the day of the week. Electrical loads may also vary depending on the day of the week, with different patterns occurring on weekdays and weekends. Thirdly, the season. Electrical loads may vary depending on the season, with higher loads occurring during the summer and winter months due to air conditioning and heating. Fourthly, the occupancy patterns. The occupancy patterns of the building will have a significant impact on the electrical loads. Finally, any unusual events. Unusual events, such as equipment failures or power outages, can also affect the electrical loads. The recorded data can be used to calculate several key metrics, including firstly, maximum demand, which is the highest current recorded during the monitoring period. Secondly, average load, which is the average current recorded during the monitoring period. Thirdly, load factor, which is the ratio of the average load to the maximum demand. Fourthly, unbalanced loads, which are the differences in current between the ungrounded conductors. These metrics can be used to assess the performance of the electrical system and identify opportunities for improvement. For example, a high maximum demand may indicate that the electrical system is undersized. A low load factor may indicate that the electrical system is being used inefficiently. Unbalanced loads can lead to overheating and other problems. Recording ammeters are a valuable tool for determining actual load in existing buildings. By following the procedures outlined above, engineers can obtain accurate and reliable data that can be used to make informed decisions about electrical system maintenance and upgrades. It is also important to consider the NEC, National Electrical Code, requirements related to load calculations and the use of recording ammeters. The NEC provides guidance on how to calculate the load for different types of occupancies and equipment. The NEC also requires that electrical systems be designed to handle the maximum expected load. Article 220 of the NEC covers branch circuit, feeder, and service calculations. This article provides methods for calculating the minimum size of conductors and overcurrent protection for various types of loads. For example, NEC Table 220.12 provides the general lighting loads by occupancy. This table specifies the minimum lighting load in volt-amps per square foot for different types of buildings. NEC Section 220.42 provides demand factors for feeders and services. Demand factors are used to reduce the calculated load based on the assumption that not all loads will be operating at the same time. The demand factors vary depending on the type of occupancy and the type of load. NEC Article 310 covers conductors for general wiring. This article provides requirements for the size, insulation, and ampacity of conductors. The ampacity of a conductor is the maximum current that the conductor can carry continuously without exceeding its temperature rating. NEC Table 310.16 provides the allowable ampacities of insulated conductors rated up to and including 2000 volts. It is important to consult the latest edition of the NEC for the most up-to-date requirements. In addition to the NEC, there may be local codes and regulations that apply to electrical installations. It is important to check with the local authorities to ensure that all electrical work is in compliance with the applicable codes and regulations. When using recording ammeters to determine actual load, it is important to follow the manufacturer's instructions for installation and operation. The ammeter should be installed in a safe and accessible location. The ammeter should be connected to the appropriate conductors. The ammeter should be configured to record data at the appropriate intervals. The data should be monitored regularly to ensure that the ammeters are functioning properly. The data should be analyzed to determine the maximum demand, average load, load factor, and unbalanced loads. The results of the analysis can be used to assess the performance of the electrical system and identify opportunities for improvement. For example, if the maximum demand is close to the capacity of the electrical system, it may be necessary to upgrade the system. If the load factor is low, it may be possible to reduce energy consumption by implementing energy efficiency measures. If there are unbalanced loads, it may be necessary to redistribute the loads to balance the system. Recording ammeters are a valuable tool for electrical engineers and other professionals who are responsible for the design, installation, and maintenance of electrical systems. By using recording ammeters to determine actual load, it is possible to ensure that electrical systems are safe, reliable, and efficient. Remember to always prioritize safety when working with electrical equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. To energize circuits before working on them. Follow all applicable safety codes and regulations. If you are not qualified to work on electrical equipment, hire a qualified electrician. Understanding the limitations of recording ammeters is crucial for accurate interpretation of data. Occupancy changes significantly impact the results. If the building's usage patterns shift during the monitoring period, the collected data might not accurately represent typical load conditions. For example, a new tenant with different equipment or operational hours can skew the results. Equipment upgrades or replacements within the monitoring period can also affect the data. Newer, more energy-efficient appliances or machinery will reduce the overall load, while older, less efficient equipment will increase it. Seasonal variations play a significant role. Electrical consumption fluctuates with the seasons, primarily due to heating, ventilation, and air conditioning, or HVAC systems. Monitoring during the summer months will capture peak cooling loads, while winter months will reflect heating demands. These seasonal peaks might not be representative of the average load throughout the year. Temporary events like construction, special events, or unusual weather conditions can create temporary spikes in electrical demand. These events should be noted and considered when analyzing the data to avoid misinterpreting them as typical usage patterns. The accuracy of recording ammeters themselves can be a limiting factor. Ensure that the ammeters are properly calibrated and maintained to provide reliable readings. Check the manufacturer's specifications for accuracy tolerances and consider these when interpreting the data. The placement of recording ammeters significantly impacts the results. Ideally, they should be installed at strategic points to capture the load of specific circuit or equipment. Incorrect placement can lead to incomplete or misleading data. Data interpretation requires expertise in electrical systems and load analysis. Simply collecting data is not enough. It must be properly analyzed to identify trends, anomalies, and potential issues. This often requires specialized software and knowledge of electrical engineering principles. Cost considerations extend beyond the initial purchase and installation. There are ongoing costs associated with data storage, analysis, and maintenance of the recording ammeters. These costs should be factored into the overall budget. Understanding these limitations is essential for making informed decisions based on the data collected by recording ammeters. It is crucial to consider these factors and interpret the data in context to avoid drawing inaccurate conclusions. Always use a combination of data analysis, engineering judgment, and knowledge of the specific building and its operations. This comprehensive approach will lead to more accurate and reliable assessments of electrical load in existing buildings. Remember that recording ammeters are just one tool in the arsenal of an electrical engineer. They should be used in conjunction with other methods such as load calculations, visual inspections, and discussions with building occupants to gain a complete understanding of the electrical system.